Hello guys, this is the second video related to Jupyter best practices. This one will be related to coding patterns and best practices related to variables naming. First video was about the structure of the notebook. I will put a link in the description if you haven't watched it yet. You can go and watch, and I won't stop on the motivation of why we speak about this at all in this video for a long time, because I have already talked about that in the first video. Generally, usage of good patterns and best practices will allow you to reduce number of mistakes you make and improve reusability of your notebooks. So all these things have direct impact on how good are you as a data scientist or data analyst or machine learning specialist. And yeah, today's video will be about two things, about variables and about the code. Let's go in the notebook and look at examples that I have prepared for you. And first things will be about variables, that they should be self-descriptive, and variables should have same sense for one variable name across entire notebook. So let me show you. I have this example. I have the structure according to advices that I was giving in the previous video. I won't stop on the notebook in detail because we are more focused on style rather than on things that are done in the notebook. And first thing, I want to show you what unclear names look like and why is it bad, and how does it generally happen that we write unclear names as variable names. And often example is when we just want to put something like a name or something in a variable, and we just define a variable like x or a and put name there. And when you are creating the code, it's 100% clear to you what you're doing, but when you will get back to that in a day or in a year, it will be hard for you to understand, and for another person it will be hard to understand even today what have you done. So it's not a good practice to give names like that. Often people also like put variable objects in TMP variables, and these TMP variables are like living for years in this notebook, because at the moment when you do that you think that it's temporary, but then it's just kept. And I have seen many notebooks with variables like TMP, and TMP doesn't have any meaning except that the author likely thought that it will be temporary, but actually it won't. So if you create TMP variable and then remove it, then okay, do that. But sometimes you will forget, and probably it's better to just not use TMP at all, just always provide meaningful names, and then it won't be a problem if some things that you thought were temporary actually came up to be not temporary. And here's one more example. So here we have variables like DBT and TMT. So sometimes people shorten variables thinking that they save something, but actually no. It's better to provide longer names like dept if it's dept, or timeout if it's timeout. If it's like execution timeout, you can write execution timeout, is okay. Of course, you shouldn't like write too long names of a variable, but 1-2 words are acceptable. Sometimes 3 words are acceptable. So don't hesitate to provide meaningful names. It will simplify reading of your code in the future. And what about variable may have good name, but there may be a problem when you change the sense or type of variable over time. So in this case, for example, in first cell, I use status to assign the result of this operation, which will be actually a SOAP element, and then I extract status text from that as status text and then print it. But in the next piece of code, I will use status to store text already. So in second cell, I will put text in the status. So here I had a DOM element, and here I have the text. Actually, it may seem like not a big problem, but in reality, when you will read the code or somebody else will read the code, people may make a mistake. They may notice that status, a DOM element, was assigned to that, and then looking at some later piece of code, they may think that it still stores the same thing, probably different value, but of the same meaning at the same type. In this case, meaning is the same, but type is different. So don't do that. It's better to just, if you have status for element, just keep status always for element and use status text for the text. So don't change the type over time. That's one more example of what may happen. So in this case, we have status element here for an element, and here we have just price for an element. In this case, it's not that obvious because in the first example we had status and status, but now it may be status here, status element here, and price, not price element here. Again, it will be harder to read this code. If you are using suffix element for an element, just use it everywhere. If you have a price, then let it be price element. Then it will be much easier to read the code. And actually, when you read the code, well-written code feels like it's obvious, and a kid would understand that. It's super obvious, like variables are too explicit, too clear to understand. That's a good feeling. You should write your code so it will produce this feeling. Don't try to make a maze out of your code. It should feel completely different to a maze. It should be 100% transparent and easy to read. And yeah, there also may be a problem with variable sense. So for example, in one piece of code, you may have xtest with some number assigned. For example, it's the result of the test. And in another piece inside the same notebook, you may have something like that. So here we assign data frame to xtest, and here you change not only the type but the sense of a variable. Don't do that within one notebook. Between different notebooks, please do what you want, but in one notebook, in one consistent piece of logic, don't assign different meanings to the same variable. It will produce errors in understanding. And yeah, here are a couple more examples of when you may use okay, so let's look here. For example, this thing with xtest, if it was a value to test, then it's better to write it explicitly that it's value to test. It's still quite short, a bit longer, but still quite short and easy to understand, and you can look at it at once. Here are a couple examples of when short names are acceptable. For example, within relatively small loops, like here. So I have a loop and I have a variable u here, which is iteration over users. It's okay to use a short name here because it's a very small scope. I don't reuse it in the different place. So that's why it will be easy to just keep in mind that u is a user and read it through. So it's okay. Then if it's a short and clear function like here, then yeah, I can also use short names. Or if it's a short name that is defined by domain. For example, in binomial distribution, we have n and p values, and thus we might have n and p. So people that will read this piece of code will likely understand that it's required by domain, and if they don't understand, they will read about binomial distribution and then understand that, okay, it's a kind of domain meaning. So you should try to write it number of elements if in the distribution is just n, right? So it's also acceptable. But in the other cases, avoid usage of meaningless and not self-descriptive variables. Just make them longer and more meaningful. Okay, so these were two things I wanted to tell you about the variables. And now let's look at several things related to the code. So first thing is that when you structure the imports, often they may go like messy. So some import there, another import there. So there is one rule that may help you to structure your imports so that it will be easier to read them. And the rule is, the more general the import is, the higher it goes in the import hierarchy. So if you have some general libraries, put them above, then add a space, and then import from your custom library. So in this case, that's my custom library, so I import from custom library here. And if there will be more imports from my custom libraries, I will put them here. If there will be more imports from general libraries, I will put them here. So in this way, imports will be quite clearly readable, and you will navigate through them quite easily. Next thing is, if you don't use pathlib path yet, I encourage you to do that, because this is quite a powerful object, simple but powerful object, which looks like that. So yeah, first I have declared this variable here, datadir, as a path. It's a path to nearby directory data, and then I can just use it by adding by querying mkdir, for example, and providing options here. You can resolve the path to get absolute path. You can get parents easily from pathlib path, and you can just add slash as an operand and create a new path out of it. So this thing will look like that. So it's really handy, and I encourage you to use that. You can do all these things with OS library, but path is just more convenient. So then, yeah, one more thing that I haven't seen people to use widely, but I use it sometimes, and it helps me to structure the code, which is when I have logical pieces of code, logically separate pieces of code in one function, I may either move them to another function or separate them somehow. You may separate them by a command like that. So this set up the options. It's okay. But also, if you don't want to write a command, you want them just to visually be separated, you can add just this if true block and optionally add a command before that. Then this tabulation here will separate this block from the code below, and you will easily understand like that. This is a connected piece of code, like interconnected. So it won't affect anything. It will just improve the readability of the code. Okay, so yeah, told you about this one. And yeah, also you can put the rarely modifiable piece of code like this function to an src folder near the notebook. So I have this notebook here, and I can create a Python file here, and later I will be able to import it and import functions from it so that they won't take space in the notebook, and I will be able to focus on modifiable logic. And I have an example of it here. So in the previous example, I had this create driver function defined. Now I have moved it to src folder nearby. Actually, it can be any folder you want. I just often use src as a source. And in order to do that, you just need to append the src to path, syspath append, and then you can import from that in this way. And that's the implementation basically. So I just moved the function with its imports to this file, and now you can just use this function as if it was defined in the notebook. Yeah, but there is actually even a better way to store the reusable code, and you can store it not in src file but in the separate Python library that you can create. And by the way, I have a video on how you can create a Python library from scratch. It will literally take you 10 minutes to do that if you know what to do, and I will put a link in the description so that you just can follow that. And yeah, you can do that, and you can move this shared code in the library. It can be private, so if it's inside your private project, you can just make the library private. Even on GitHub, you can make private libraries and input from them. It's also possible. I won't stop on that in detail because I just have a separate video for that. Yeah, and moving the code to a Python file has one, generally moving the code in a function has one non-good side effect, that if there will be a bug in a function, it will be harder for you to debug it. Because if your code is written like that without any function, then you can just print anything at any moment of time. You can modify it and rerun the cell, right? But once you have a function, it's harder. And what you can do, I will show you a couple tricks of what you can do in this case. What you can do is, if you have a code that you want to debug or execute at prints at particular places, what you can do is you can print this function with its imports, insert it in the cell, then command the function header and add if true here. Basically, it will allow you not to adjust tabs then. And the one remaining thing is that you need to assign values to function parameters here at the beginning. And that's it. So now you can execute this piece of code as if it was defined in your, you will need to command the return also. Now you just need, you can execute it as if it was not a function at all, right? And now I can add prints, or okay, we'll switch back here. This window was opened by the code, and yeah. So now I can add print somewhere, like, and it will be printed, see? So quite easy. And then once you have finished the debug, you just copy the logic from here, from here, and move it back to the function, and just save it. Right. But you can actually do even better. So if you want to debug the code, a better option is to use VSCode for that. VSCode code is super handy, and it allows you to connect the debugger to your notebook code. So I will show you what it looks like. So I have a VS Code here, and yeah, I've just executed these cells. And let's say I have some problem with this create driver function. I can do Control or Command click on the function to go to definition here, which is not possible in Jupyter. And now I see the file is selected, and now I can set up a breakpoint, for example here. So I have created this red dot, and then I click here and run debug cell, and yeah, the code just stops in this moment. I can just execute it line by line and see what's stored in particular variable, right? So you have debugger, and you can just do whatever you want in the debugger. It may require some steps for you to set up VS Code, but when you will do that, you will benefit from it a lot. If you want me to make a video on VS Code and how to use it, how to set up it, write a comment, and I will probably do that. Yeah, so super handy. Encourage you to use VS Code. And that's it for this video. I will have at least one more video on notebooks best practices related to how you can structure the data, how you can optimize the data, cache the data, etc., etc. Several more best practices to share. So follow new videos, and I will share it soon. For now, that's it. Thank you for watching, and see you soon.